Welcome to this tutorial on the section formula. We will derive the formula for the internal division and the external division. So these formulae are called the section formula. And we know the special case for the section formula is the midpoint. But we are going to talk about the internal division and external division in this video. So the division is a line segment, or the line is a directed line segment. So it means the order is very important. The order is very important. Or the direction is very, very important. Now, there's another channel that I would like you to subscribe to. I upload videos on those channels too. So kindly subscribe to this channel. You can type this and it will take you to that channel. And thanks in advance for your subscription. Now let's look at what we call the internal division of a line. So we have line AB and we have a point C. A has coordinates x1, y1. B has coordinates x2, y2. A to B is M, C to B is N. A to B is M plus N. Now we can use the similar triangles. Similar triangle A, B, D. Let me put D here. So similar triangle ABD. Let me put E here too and see. So we can use similar triangles for triangle ACE and triangle ABD to calculate for the coordinate of point C. So we know that the distance from this point to point A, this point E over here to point A, horizontally will be x minus x1. And if we take that distance over here over the distance of the bigger triangle, which is AD, so AE over AD, in terms of coordinate wise, we have x minus x1 over, so then the x coordinate of D will be x2, so x2 minus x1. Good. So that will be also proportional to the hypotenuse. So the hypotenuse of the smaller triangle is m, and the hypotenuse of the bigger triangle is m plus n. Now we can cross multiply. So this will multiply this, and this will multiply this. That will give us this equation. The next thing we can do is to expand. So let's expand. X will multiply to get xm plus xn or nx. Then this will take on this minus mx1 minus nx1. Then on the right too, we expand to get mx2 minus mx1. So that will give us this relation over here. What we do next, we have to group like terms. The group like terms, we are moving the ones with x on one side, and also those with the subscripts. So mx2 plus nx1 plus minus nx1 plus mx2 plus mx1. So that is what we had here. So the minus mx1 is already here, and this one comes to add. Good. Then we have negative nx1 also coming to add on the right hand side. Now this and this will cancel out, so that we are left with this expression and this, where we can factor x out of the left hand side. Now x is what we are looking for, so we solve for x to obtain x is equal to m times x2 plus nx1 over m plus n. We can use a similar approach to solve for the coordinate of y. So using a similar approach, we have y minus y1 over y2 minus y1. So y minus y1 is this. So y minus y1, the coordinate of e, the y coordinate of e here will be y1 over, so this distance is what we are calculating, CE. Then we also have BD. BD will be y2 minus y1. So this, the y coordinate of this point is y1, and the y coordinate of this point is y1. That will give us this relation. So it is also proportional to the hypotenuse. So we cross multiply, then we expand to get this. We group the terms with the y on the left, and all other terms going to the right. This and this cancelling out. Then we have m plus n. When we factor this, times y will be equal to m times y2 plus n times y1. So we divide both sides by m plus n to get y equal my2 plus ny1 over m plus n. When we simplify, this is what we are getting for the coordinate of x and y. So we can use this to calculate the coordinate of C along any point on this line. It could be the midpoint, and we'll still get the same. We'll get the coordinates of the point xy. So let's take an example. So let's recall that this is what will give us the coordinates of any point that is dividing the line segment AB internally in the ratio m is to n. This will give us the coordinate of any point that is dividing the line segment AB internally in the ratio m is to n. So let's take our first example. What are the coordinates of the point that divides the line segment A, negative 1, 1 to B, 5, 7, 5, 4 internally in the ratio 2:1? So we recall our formula: m times x2 plus n times x1 all over m plus n. Then my2 plus n y1 over m plus n. So remember that the first ratio multiplies the second coordinate, and the second ratio multiplies the first coordinate. The same thing applies to the y. The first ratio m multiplies the second coordinate of y, and the second rather multiply the first coordinate of y. Now, from the given points, we can write down x1 to be negative 1, x2 to be 5, y1 is 1, y2 is 4. If you change the order, you get it wrong because the line segment is along A to B, from A to B. Then we have the ratio 2:1, so m is 2, n is equal to 1. Now let's substitute into this formula. When we substitute this into the formula, we get this. So this will give us 10 minus 1, and this will also give us 8 plus 1 all over 3. So this will give us 9 over 3 and 9 over 3. So the answer will be 3, 3. Now let us take another example. Find the coordinates of the point which divides the line segment joining the points 4, 6 and negative 5, negative 4 internally in the ratio 3:2. So we recall the formula: m times x2 plus n times x1 all over m plus n. M y2 plus n y1 all over m plus n. Now, from the question, we can write down the values of m, n, x1, x2, y1, y2. So these are the values we are going to substitute into the formula. So when we do the substitution, we get this expression. So 3 times negative 5 will give us negative 15. 2 times 4 will give us 8. 3 times negative 4 will give us negative 12. And 2 times 6 will give us 12. Now, let's simplify. This will give us negative 7 over 5, and this will give us 0 over 5. So we have negative 1 whole number, 2 over 5, and 0. So that is the coordinate of the point which divides 4, 6, negative 5, negative 4 in the ratio 3:2. Now, I would like you to try this one. Find the coordinates of the point which divides the line segment joining the points 2, 10 and 7, 5 internally. The ratio 3:2. After 1 minute, I'm giving you just 1 minute to finish. So let's see how we can do it together and see whether you had it correct. So you record the formula, then you do the substitution for m equal 3, n equal 2, x1 equal 2, x2 equal 7, y1 equal 10, y2 is equal to 5. So let's do the substitution to get this. So 3, 7 will give you 21, 2, 2, 4, 3, 5, 15, 2, 10, 20, all over 5. So this will give you 25 over 5 and 35 over 5. When we simplify, we obtain 5, 7. So the point which divides the line segment joining 2, 10 and 7, 5 in the ratio 3:2 internally is 5, 7. Here is another one. Kindly try this one too for just 1 minute. All right. So let's also look at the solution. So this time our m is 2, n is 3, x1 is equal to 2, x2 is equal to 7, y1 is 10, y2 is 5. Let's do the substitution into the formula to obtain this. Now let's simplify. 2, 7, 14 plus 3, 2, 6, 2, 5, 10, 3, 10, 30, all over 5. Now this will give you 20 and this will give you 40. So 20 over 5 is 4 and 40 over 5 is 8. Hence the point that divides the line segment joining the points 2, 10 and 7, 5 internally in the ratio 2:5 is 4, 8. Now let's proceed to the external division of a line. So this time the line segment AB and the point C that divides this line segment is not within the interval A to B, but outside in the ratio m is to n. So this time the m is from A to C and the n is from B to C. Now, how do we derive an expression or a formula that can help us calculate the coordinate of C? So this time we have a line, so we can use the coordinate. The distance from A to C is m. In terms of coordinate, it will be x minus x1. So x minus x1 over m will be proportional to x minus x2 over n. So when we cross multiply, we get something like this. So we are now going to expand. We will expand to get nx minus nx1 is equal to mx minus mx2. Now let's group the terms. Let's group the terms with x on the right and the terms with x sub 1, x sub 2 on the left. So we can now factor x over here, and that will give us m minus n times x. Dividing through by m minus n, where m minus n is not equal to 0. Then we obtain the formula x is equal to x2 minus n times x1 all over m minus n. So in this case, m is not equal to n because we'll get division by 0 in that case. So we can use a similar approach to find the y coordinate of C. So when we simplify this one too, we have y to be equal to m times y2 minus n times y1 all over m minus n. So let us see how we can use this one to solve questions. So we have our example here. Find the coordinates of the point P which divides the interval s -3, -7 and t -1, -4 externally in the ratio 4:3. So we recall the formula m times x2 minus n times x1 over m minus n, and m times y2 minus n y1 over m minus n. So we have m to be equal to 4, n equal 3, then we also have x1 equal -1, y1 equal -7, and y2 equal -4. So let's do the substitution into the formula to obtain something like this. So when we multiply, we get -1 plus 9, and this one will give us -16 plus 21. So all divided by 1, So that will give us 5, 5. So the point P has coordinate 5, 5. Let's take another example. We have to find the coordinates of the point P, which divides the line segment A 4, 5, B 5, 4 externally in the ratio 3:2. So, like before, we will record the formula, and we have our M to be 3, our N to be 2, X1 equal 4, X2 equal 5, Y1 equal 5, Y2 equal 4. So we do the substitution, and that will give us this. Now let's multiply 3, 5, 15, 2, 4, 8, and we have 3, 4, 12 minus 2, 5, 10. So all this will simplify to 7/1 and 2/1. Hence, P has coordinates 7, 2. So that is how we use the external division of a line formula to calculate for the points that divides the line segment AB in the ratio 3:2 externally. Now, if you can still see this red thing here, it means you have not yet subscribed. So you just have to click it so that the next upload, you see it is still red. You have to click it so that if I upload the next video, you'll be informed. Click the bell icon too, so that you get a notification whenever I upload a new video. Thanks for watching. Don't forget to subscribe.